So now it's time to prove that limit sine x over x when x tends to 0 equals 1. Let's assume that we have the unit circle and its radius equals 1 length unit, as you see in this figure. And now let's draw our angle x. So starting from the origin, let's say this is my angle, so this is x, my angle x. And let's name these points just like A, B, C, for example. So now I want to talk about three shapes. The first one is the sector ABC. Let's talk about the area. So now I have the area of sector ABC. And the second shape is the triangle ABC. So let's draw this one like that. So now I have a triangle ABC. It seems clearly that the triangle of ABC, its area is smaller than the area of the sector, because we have an extra area like this one, this segment. So this is an extra area, or the difference between the area of the triangle and the segment. So now I can write now the following, that I have the area of triangle ABC is smaller than the area of the sector ABC. Now let's assume that we are going to draw a tangent of the circle at the point B. So I think it should be like the following. Now I have to draw this one. So this tangent, and the tangent for sure that makes an right angle. And let's say this point is D. So now we have another triangle called ABD. And of course, the area of triangle ABD is bigger than the both we have talked about, because the triangle is a part of this triangle. The triangle ABC is part of the triangle ABD, and the sector ABC is part of the triangle ABD. So now I can say this area is smaller than the area of triangle ABD. So now our mission is to find or calculate the area of these three shapes. Don't forget that I have the radius equals 1, so this part equals 1 and this part equals 1. So now let's start. Concerning the triangle ABC, the area is the half times 2 sides times sine the included angle. So let's say it's a half of AB times AC times sine x. So now I can say that, and don't forget that AB and AC, all of them equals 1, so it's half times 1 sine x. So now I can say that sine x, half sine x. This is the area of the triangle ABC. Let's do something like that concerning the area of the sector ABC. So the sector ABC, the area called half radius squared times the angle theta, or I mean the angle of the sector. So in our case, this angle the same x. So I can say it's half times r squared, and r equals 1, and the theta is x. So now I can say it's half x. So this is the final step I need to go. Now the third shape, the triangle of ABD, let's talk about its area. It's going to be the same like the first one. It's half times 2 sides times the sine of the included angle. So this is my half, and let's say our 2 sides are the BD and AB. So now I can say it's a half times AB times BD times the included angle, which is B90, so it's 990 degree. So sine 90 means 1, you know. So now it's half AB, and the AB is 1 times BD, we don't know yet the value of it, times 1. So now I can say it's half BD. Let's talk about the BD. The BD in the triangle ABD, we can say that the tan x, I mean in the triangle ABD, so tan x equal the opposite of the x, which is BD, over the adjacent one, which is AB, which is 1. So now I can say that BD equals tan x. So now I can substitute BD by tan x. So now I can say, I can remove this BD and write instead of it tan x. So now I have this inequality. So first of all, let's remove this half. So by multiplying by 2 or removing half directly as you like. So now I can say that sine x is smaller than x, smaller than tan x. Now it's time to make the tan x, to convert it to sine over cosine. So now I can say it's a sine x is smaller than x is smaller than sine x over cosine x. Now let's make the reciprocal of this inequality that makes every numerator being denominator and the vice versa. So I can say this is like over 1, like over 1. So now I can say 1 over sine x is, I'm sorry, 1 over sine x, and now 1 over x, and now cosine x over sine x. So when we make the reciprocal, so we have to switch the operator. So instead of smaller than, it's going to be greater than, just like 2 is smaller than 7. But if we said 1 over 2 and 1 over 7, so in this case we have to switch the operator because 1 over 2 is greater than 1 over 7. Now I can, now we can multiply all the inequality by sine x. So let's say this is times sine x, so it means 1 is greater than sine x over x and greater than cosine x, because sine x is cancelled with sine x. Now this is the situation, but let's write it in from left to right. So now I can say it's a cosine x is smaller than sine x over x is smaller than 1. So according to this inequality, I can say that let's go to the limits. So now I can say limit the same inequality. So limit x tends to 0 for the cosine x is smaller than limit x tends to 0 to sine x over x, smaller than limit x x tends to 0 for 1, only 1. So now cosine x, when we substitute by 0, so the result is 1. So the smaller than, this is limit that I'm going to looking for, so it's going to be the same sine x over x. And now this is smaller than limit 1, so it's going to be 1. So now I can say that limit x tends to 0 and sine x over x, so it's greater than 1 and smaller than 1. So now I can say directly that, so the limit of x tends to 0 for sine x over x equals 1. Thank you for watching.